Hello, everyone. In this video, we'll show you how to set up real-time Change Data Capture CDC from PostgreSQL to Salesforce using SKYVVA Agent. In this scenario, you will learn how to use PostgreSQL Change Data Capture, or CDC, with the SKYVVA Agent to automatically synchronize database changes with Salesforce. PostgreSQL CDC captures insert, update, and delete changes using write-ahead logging and logical replication. The SKYVVA Agent processes these changes and streams them to Salesforce without repeatedly querying the entire database. Here is how the end-to-end flow works. First, an insert, update, or delete occurs in PostgreSQL. PostgreSQL records the change in the write-ahead log, or WEL. Logical replication makes selected table changes available through a publication, while a replication slot keeps track of the consumer position. The SKYVVA Agent acts as the replication consumer and reads the change events from the replication slot. SKYVVA then applies mapping, transformation, business rules, and error handling. Finally, the process changes are synchronized to Salesforce as insert, update, or delete operations. To support this flow, PostgreSQL must have wall_level set to logical, a publication for the target tables, a replication slot, and sufficient WEL senders. The most important point is that no PostgreSQL subscription is required. The SKYVVA Agent itself acts as the replication consumer and handles the CDC streaming process. You'll also need to confirm that your SKYVVA Agent is active, running, and connected to your Salesforce org. Finally, make sure all core SKYVVA components are prepared, including your integration, connection destination, adapter, metadata providers, repository, message type, and interface. What you will learn, by the end of this video, you'll understand how to configure the core SKYVVA components, enable database CDC directly on your SKYVVA interface, and capture real-time changes from PostgreSQL. You'll then stream those changes through the SKYVVA Agent and deliver them instantly to Salesforce. Now, let's start. First, you should enable logical replication on the PostgreSQL instance. Navigate to pgadmin. As the PostgreSQL administrator, use this command to update the system in Postgres. You can select it and click Execute. These parameters require a PostgreSQL server restart to take effect. In particular, wall_level is a server start parameter. You can check the requirements on the PostgreSQL website. After running alter system, restart the server. Once the PostgreSQL service has restarted, verify the configuration. Here is the wall_level, show logical. Here is the max_wall_senders, show 10. Means PostgreSQL allows up to 10 concurrent WEL sender processes. Here is the max_replication_slots. Show 10 means PostgreSQL allows up to 10 replication slots to exist at the same time. We are currently using the database enable_CDC_DB, schema, table_CDC, and table, account_DB. Since we have already created these, we will use the existing ones. Then create a database user with access to the schema and tables. Make sure it has superuser permissions to create subscriptions, or just use the admin user if you don't want to make a new one. Next, verify the role for the CDC user. There are the role name for the user SKYVVA_CDC. Then, verify the database, schema, and table permissions. These are the permissions for the user SKYVVA_CDC. Currently, we have completed the core PostgreSQL configuration to enable CDC. However, the overall setup is not fully finished. For tasks such as creating the publication and replication slot, Our interface will automatically generate them for you based on the configuration once you start the streaming API. Next, navigate to the SKYVVA Integration Cloud. We'll be using our existing integration. From there, go to the Agent Control Board. As we showed you earlier, this is where we set up the connection destination. Now, navigate to the Adapter tab to configure PostgreSQL. Inside the adapter configuration, click Edit on the PostgreSQL adapter. Although the configuration screen looks identical to other database adapters, select the inbound direction and provide PostgreSQL-specific connection details, including the JDBC driver class, database type, PostgreSQL, username, and password, which must have superuser permissions on the CDC database. Additionally, enter the host name, port, database name, and schema name enabled for CDC, along with the database URL and the connection destination. Once configured, click Ping Connection to verify that the SKYVVA agent can successfully communicate with PostgreSQL. A successful connection confirms the adapter is ready for use. Now, navigate to Integration, then click on the Interface tab. We have already created the interface. In the interface, the source name contains account object. Set synchronous processing mode, link it with the message type, and the inbound direction. For the operation type, we're using the insert operation, the interface type, event interface. Then, scroll down to the events configuration section. Click Event Type and select Database CDC Event. Next, configure Notification for Operation to select the event operation type you want to send to Salesforce, for example, Insert. In this step, we will select Create to capture new record insertions into the table and send the data to Salesforce. Once you've done, click Save the interface. Then, click the Open Mapping button. Here, we'll map our PostgreSQL tables to Salesforce objects, such as account. As you know, with the insert operation in Salesforce, there's no need to set an external ID. Once you've completed the mapping, click Save to finish. Don't forget to link the adapter in the interface. Next, head over to the Agent Control Board and click the Interface tab. Here is the interface in the list that we have linked to the PostgreSQL adapter. And click Start Streaming API. Once clicked, a success notification will appear stating, "Started streaming API successfully." This establishes a continuous background listener, capturing CDC events in PostgreSQL and streaming them directly into Salesforce in real time. Now, let's insert a record into the table. Open pgadmin. Before running our insert command, let's execute a quick select query to check what's currently in the table. We can see the existing records inside account_DB. Now let's run the insert command to add our new record. And run a quick select query to confirm the record was added. As you can see, the new record has been inserted with db_cc_pk set to 18. Next, switch over to message monitoring. And click Apply Filter. You'll see an agent message monitoring log marked Inbound API Call alongside the business message, Insertion of Account. Click on the message to open the message detail page. It displays a green status for the agent message, along with successful business message comments, such as insertion of account and the actual payload data values. Finally, click the account link to open it in Salesforce. As you can see, the row we just inserted into PostgreSQL has been automatically created as a new account record in Salesforce. All field values have been mapped over perfectly in real time, completely eliminating the need for manual batch processing or scheduled cron jobs. Currently, we will show you another step of the update operation, the use case related to updating a record in the table, and then also updating the record on Salesforce too. Now, go to the existing interface, click Edit Interface. Select Update Operation Type. And scroll down to set Update on the Notification of Operation field. Then click Save the interface. Next, click the Open Mapping button. We'll map our PostgreSQL tables to Salesforce objects, such as account. As you know, with the update operation in Salesforce, there is a need to set an external ID. Once you've completed the mapping, click Save to finish. Important tip: anytime you update the interface configuration, like changing the operation type from insert to update, you need to restart the streaming API. Make sure to restart the stream on the agent control board so your new settings take effect. Next, head over to the agent control board, click the Interface tab, and click Start Streaming API. You should see a confirmation alert saying Started Streaming API successfully. Now, let's update a record in the table. Open pgadmin. Before executing our update command, let's run a quick select query to verify the current record in the database. As you can see, the record with db_ac_pk equals 18 currently has its billing city set to New York. Now, let's execute the update statement to change the billing city to San Francisco. And run a quick select query to confirm the changes. As you can see, the billing city for this record has been successfully updated from New York to San Francisco. Next, switch over to message monitoring. You'll see an agent message monitoring log marked Inbound API Call alongside the business message Update of Account. Click on the message to open the message detail page. It displays a green status for the agent message, along with successful business message comments, such as Update of Account, and the actual updated payload data values. Finally, let's click the account link to inspect the updated record right inside Salesforce. As you can see, the exact changes we just executed in our database, updating the billing city to San Francisco, have been applied in Salesforce instantly. Change Data Capture caught the update in real time, pushing the modified data across systems with zero manual intervention. In the last step, we will show you the delete operation, the use case related to deleting a record from the table and automatically removing the corresponding record in Salesforce as well. Now, click Edit the existing interface. Select Delete for the operation type. And scroll down to set Delete on the notification for operation field. Then click Save the interface. For the mapping, we don't need to change anything. Next, navigate to the Agent Control Board and click Start Streaming API. You should see a confirmation alert saying Started Streaming API successfully. Now, let's delete a record from the table. Before executing the delete command, let's run a quick select query to confirm that the record currently exists in our PostgreSQL table. As you can see, the record is present right here. Now, let's run the delete command to remove those records from the table and run another quick select query to confirm the removal. Notice that the record is no longer present in the table. Next, navigate to Message Monitoring. You'll see an agent message monitoring log marked Inbound API Call, alongside the business message, Deletion of Account. Click on the message to open the message detail page. It displays a green status for the agent message, along with successful business message comments, such as Deletion of Account, confirming the deletion request was processed. Finally, navigate to Salesforce and refresh your account view to verify the deletion. As soon as we inspect our accounts, we can see that the record we just deleted from PostgreSQL is completely gone in Salesforce as well. The deletion was detected and processed in real time, keeping both systems perfectly in sync with zero manual triggers or cron jobs required. To summarize, in this video, we demonstrated how to enable Change Data Capture in PostgreSQL, configure it using SKYVVA functions, and capture, insert, update, and delete events directly from your database using the Agent Streaming API. By leveraging the Inbound Agent Database Adapter, every change is continuously processed and synchronized to Salesforce in real time. Thanks for tuning in. Don't forget to check the video description for helpful documentation links, and make sure to subscribe so you never miss an update. Thank you for watching. See you in the next video.